Yeah, so we applied gamma correction, and then we also did some data augmentation, which I'll go through. So here's kind of so I kind of went back, and because I wasn't sure, maybe we were making some mistakes in the process, so I created this notebook, which just to make sure that there weren't mistakes as we go through. So from the original images, we started including our latest annotation, so about 2,000 images. We converted the XML files to the CSV. That ended up giving us, with all the annotations, about 12,600 different annotations. Then we added the gamma correction, which Rosen just showed you. Basically the same thing, but our original image, a darker image, a brighter image. And we also created those images, and then also created since they're using the same XML file, we just basically could copy the original image XML information, and just link it to the new file with the gamma corrected images. So you can see here that took us from 12,600 to about 38,000. That's just 3 times as much. So that makes sense. And then we wanted to apply some data augmentation, so we flipped them horizontally. So this is the original picture on the left, and then we also created this flipped version on the right here. And we did that with the gamma adjusted images as well. And so basically, we weren't able to use the same XML information because it had been offline.
We are not able to hear you, Devin.
450.
Devin, there is some issue from sound.
Okay, yeah, it's saying I have poor connection, but right now it says it's okay. Can you hear me right now?
Yes, we can hear you now. Now it's fine, I guess.
Okay, hopefully it stays fine. But you can see that when we flip the X's will change, and so we just need to take the furthest point on the side here, which is 640 from our X direction, and subtract, and that will give us our new X's. And so if I take the maximum X value from here, which is 92, and I do 640 minus 92, that's going to give me 548, so that becomes actually the new minimum. So 640 minus 92, 640 minus the X max becomes the new X min value, and then 640 minus our X minimum value, 66, becomes our new X maximum value. So you can see that in the code here. New X min is we're taking the information from our horizontally flipped image and just doing 640 minus X, and our new X max is taking the minimum value and doing 640 minus the minimum. So that gave us all our information. I guess I didn't print this out, but basically multiply this by 2. So that's 76,000 different data points. Then we split them into train and test sets. And then from there, we could generate our TF records for our model. And so here's just kind of an example of everything that it did. So we start with our original image here. It had 3 different annotations. And then you can see that when we adjust the gamma, the annotations don't change because the objects are still in the same place. But here, when we're flipping them, we can see that the X and Xmin and Xmax values are changing because they're in a new location. So I've been running the model for a while, and it is just basically flattening the loss curve here at 4. So we still need to work on ways to get that down. I'm thinking we might want to adjust the learning rate or something at that point. But the output is looking better, so we can go to our output here. It seems to be kind of detecting most things in the distance as a car. Oops. Oh, what happened? Yeah, it seems to be detecting most things in the distance as a car, and then as you get closer, it will correct and identify it more correctly. But it seems to be detecting more objects overall, which is good. And so we'll kind of go up to that same point where Rowan was showing his video. Oh, this is being so slow. It's not moving. But anyway, even if we stop right here, we can see that's a car that's properly identified. There's a motorbike right there. That's a car. Bus, that's correct. So it's definitely improving from what we were before. And like I said, that that's a good sense. I think I'm having some internet issues, but hopefully you could hear most